Distance from the Sun to Mercury, 1 Mercury unit of distance, we see roughly the following spacing for the planets. The gap between Mars and Jupiter looks like a perfect place for another planet to have formed. But instead, there is a wide zone of rocks and dust called the asteroid belt. Although this is the place where most asteroids are found, don't expect to see anything spectacular in that area of the solar system. You see, it's really only a ring of dust, sand, boulders, and mountain-sized chunks spread out in bands much like the rings around Saturn. But if all the bits and pieces were squeezed together in a single ball, it wouldn't even be as big as the Earth's moon. Also, there's so much space in the orbit around the Sun that no hint of a ring is visible, even though from Earth we'd see it in its most concentrated view, edge on. Scientists once thought asteroids were the remains of a gigantic collision between planets, but the current theory is that the strong gravity interaction between Jupiter and the Sun prevented a planet from growing from the material that made the solar system. We've located and named about 3,000 of the largest asteroids, and we're adding more to the list each year. At almost 600 miles across, Ceres holds the record for size, followed by Vesta and Pallas at almost 350 miles apiece. But not all asteroids are confined to the asteroid belt. Some merely pass through it, and some never enter it at all. One group of unusual asteroids seem to chaperone the planet Jupiter. They're called the Trojans, and some of them lead the giant planet in its orbit. Others follow. Another category of asteroids is the chaotic group. They are asteroids that wander in and out of the orbits of the planets, some moving in wildly strange ways. Most asteroids don't pose a hazard to Earth. They're not in positions likely to be deflected by any gravitational forces into our planet's path, and they are far away. In a certain light, their great distance from us is a drawback. They may be valuable for their minerals, but they're too far away to be useful anytime soon. Asteroids that pose the main threat to Earth are called the near-Earthers. There are 3 main groups of these: Aten, Apollo, and Amur. The Aten asteroids orbit mostly between Earth and Venus. The Apollo asteroids orbit mostly between Earth and Mars, and the Amur asteroids orbit entirely between Earth and Mars. Some of these asteroids already have orbits that cross ours. The others are close enough so that a slight bump could send them careening into our way without much difficulty. So far, we've located about 150 of these near-Earth asteroids, and NASA estimates that thousands of others in the mile-wide range may yet be discovered.
Anyway, they're out there. They collide with the Earth. We think we even know sort of the frequency of collision. Every 100 million years to billion years, we expect a fairly big, hefty asteroid to be available, statistically, to collide with the Earth.
We'll return to the Practical Guide to the Universe on the Learning Channel. We now return to the Practical Guide to the Universe on the Learning Channel. The near-Earth asteroids are a danger, but they also offer the most promise if we ever want to develop local space as a frontier. You see, one of the big difficulties slowing our progress into space is the huge cost of sending materials up into orbit. Every item in a spaceship requires the expenditure of huge amounts of energy as it climbs out away from the Earth. We pay an enormous fuel bill for each satellite launch. If we could mine materials already in space, we'd cut the fuel consumption considerably. The moon is the most obvious source of materials already in space. Its gravity is 1/6 as strong as Earth's, so it should be 6 times more economical to mine on the moon and then send the processed materials into space. But the moon doesn't have much in the way of useful minerals lying around on the surface. To get the materials we need, we'd have to dig deep below the crust. On the other hand, asteroids have no significant gravity and offer a wide variety of mineral types. Most of them contain an abundance of valuable metals. Some of the asteroids are the heads of dead comets. These comets have ammonia and water vapor trapped within the rock. Minerals we'll need to keep us alive in space. Another advantage of the asteroids is the accessibility of the minerals they possess. Think of asteroids as a moon which has already been broken up, ready to be further processed. An expensive first step is already accomplished. It's far too expensive for us to fly to the asteroid belt just to get minerals because of the fuel needed to get there and return. But at certain times, the near-Earth asteroids are closer to the Earth than our moon is. These objects are an inexpensive source of minerals in space. An asteroid in the range of 1 to 2 miles in diameter would support a space colony of 20,000 or so for many years as its particular riches are extracted. And this is not just a fantasy. Some have estimated that the near-Earth asteroids contain trillions of dollars worth of nickel and iron. We could produce steel of extraordinary quality on these asteroids. Metal made in a vacuum is much stronger because there's no oxygen to weaken it. The threat and benefit of near-Earth asteroids should make them one of our first targets as we move into space. If we do nothing, we may find the end of civilization and perhaps humanity is the result of our inaction. Nature may be kind and send us a warning in the form of a small asteroid, one which only destroys New York or Moscow or Tokyo, and maybe it will hit an uninhabited area like Antarctica or a sparsely populated area like the Sahara Desert. Even there, we would have changes in the global weather which could spawn crop failures and famine. Thousands, perhaps millions, would die. Certainly then, we would mount a space program which would remedy the threat. If nature is unkind.
If it were to occur, if you think a hurricane had a large human effect, I mean, aside from the local effect, imagine something that would put the Earth in, near twilight darkness levels for a month, that would produce acid rain fallouts 1,000 times those we're experiencing in the worst situations on the Earth around large industrial centers. I mean, and this might go on for years. And the total, these kind of catastrophic events to our Earth, unfortunately, are so beyond belief, they're not included in the models that we're now developing.
The lesson of geologic time is that the Earth has undergone several mass extinctions over its lifetime. One which ended the age of the dinosaurs killed off 90% of all life on the planet.
There are potentially thousands to millions of these Earth-crossing asteroids that are ready with a slight shove in the right direction to collide with our Earth. And they're going to. There's no question. The fact that you and I don't wander out our backyard and see a nice big hole there like we would if we lived on the moon or Mars, for example, doesn't mean that they're not going to happen.
So the threat is real, but their promise is also real. On the eve of the 21st century, many people worry about the destruction of the world environment. What we do today can affect the entire planet. Right now, we have no place to go if we mess up. But that doesn't have to be planet if we have the foresight. Asteroids can be one of the stepping stones to space. The degradation of the world environment will not end our species. In learning how to live in space, the microcosms we must create will teach us how to better treat the planet we live on. Space can be initially an insurance policy for mistakes we may have made here on Earth, and later, a place to emigrate for those seeking adventure, or merely to get away from it all. In any event, we now know that there is a second, very real reason for keeping our eyes on the heavens, for sometimes stars do fall from the sky, with disastrous consequences for the unprepared.